increased use of stonework has intensified pressure within the stone industry to improve production techniques. Debeers diamonds have played a major part in these improvements. Over 400 years ago, sculptors such as Michelangelo came to these mountains of marble in northern Tuscany to select their stone. Nowadays, sculptors still come to this quarry, set high above the town of Carrara in the Apennine Mountains. But this famous marble is mainly destined to become cladding for the floors and walls of hotels, offices, and homes throughout the world. The extraction of these huge blocks has been transformed by the use of diamond electroplated wire saws. It was in 1981 that this first became the standard means of block extraction. This block of marble is 80 feet long and 45 feet high, and is the biggest block ever to be cut in Tuscany. The wire is first pulled through by hand. The sawing is carried out by electroplated diamond abrasive beads, 1/4 inch long and 3/8 of an inch diameter. To allow free running of the saw at the start of the cutting process, an extra pulley was positioned just above the exit point, which can be removed when the corner has been rounded off. A 70 horsepower motor pulls the 260-foot wire through the marble at a cutting rate of 110 square feet per hour. The diamond wire saw will cut this huge block in just 30 hours. Only a few years ago, it would have taken up to 2 weeks with abrasive slurry carried by a steel cable hundreds of feet long, running the entire length of the quarry through numerous pulleys. These pulleys now lie rusting on the mountain as the diamond wire method has become the standard. This same technique is used in the quarry to cut the marble into manageable blocks for transportation. These wires have a life expectancy of 12,500 square feet, 7 times that achieved during the initial trials. Marble continues to be in demand from these quarries, which have been supplying the building trade since Roman times. The introduction of diamond wires has revolutionized quarrying techniques, making the process both faster and more reliable. Because of its hardness, the traditional method of extracting granite blocks from the quarry face is by means of explosives. However, blocks produced by this method have irregular sides, and subsequent processing is both time-consuming and wasteful. The latest development for quarrying granite is the use of a wire with diamond-impregnated beads. A plastic coating protects the wire from the abrasive slurry. Here, a medium hard granite, Vosges, is being cut with diamond beads just under ½ inch diameter. The 40 horsepower motor drives the wire at 5,900 surface feet per minute. This latest development is likely to become standard in granite quarries within the next few years. Situated just inland from the English Channel lies Carrière du Boulonnais, where wall cladding is produced from initial quarrying to the finished product. Here, unlike in the mountains of Italy, the marble is located below the general surface level, and large craters appear as the marble is removed for processing. another advantage of this method of extraction is the dimensionally accurate surface which results, thus making subsequent processing considerably easier. Within the quarry area, the blocks of marble are squared off and cut to size using diamond-bladed saws. The first stage of the tile production line is to split the stone blocks into smaller slabs. The machine uses both vertical and horizontal circular saw blades. Two banks of 5 vertical blades saw the slabs into the approximate tile thickness. The first bank of blades, 24 inches in diameter, cut halfway through the material. The second bank, 40 inches in diameter, completes the cut to full depth. A diamond milling head at the start of the polishing line ensures consistent thickness of the finished tiles. At every stage of the process, from quarry through to finished tile, diamond plays an important role. Frame sawing of marble and softer stone with diamond is now the accepted method, as a straighter, cleaner cut is achieved approximately 10 times faster than the old swinging frame machines using loose abrasive. Each of these 70 blades has 30 segments containing natural diamond abrasive. Cutting 1-inch thick slabs of yellow Jura marble at 100 strokes per minute, the saw has a downfeed of 10 inches an hour. Granite is usually cut into slabs by large circular saws. One of the largest in Europe is the Carl Mayer computer-controlled block saw with an 11.5-foot diameter blade utilizing 180 segments, approximately 9/10 of an inch long. On this South African Impala granite, a half-inch depth of cut at a cutting rate of over 8 feet per minute is achieved. At these parameters, the blade has a life expectancy of 10,000 square feet before retipping. The computer control enables the machine to be programmed for 250 separate cuts on 2 blocks of granite, and may be left over the weekend to complete the work. Other machines have also been developed for the slabbing of granite. The Nordiax machine uses a novel technique. The saw blade is concave and mounted vertically, and the sawing frame moves back and forth to keep the cutting edges on the concave blade in contact with the stone. The infeed is controlled by pulling the stone toward the blade. great advantage of this machine is the straight, smooth cut it achieves, which reduces the time spent for subsequent milling and polishing operations. Another granite slabbing technique involves a bandsaw. The cutting tool has diamond-impregnated segments raised to a steel band 56 feet long. Initial problems with fracture of the steel band were overcome by introducing a gentle rocking movement of the workpiece material, which reduced the overall contact area of the band with the stone. The bandsaw produces less waste than a circular saw blade due to the reduced thickness of the segments. Two blocks may be cut at the same time, one on each side of the machine. The blocks have independent crossfeeds so that each block may be cut into slabs of different thicknesses. Italian tile manufacturers import granite from around the world to meet increasing demand. Much of this company's production is exported. The initial slabbing is done by 20 circular saw blades, which can be spaced to cut slabs between 1 centimeter and 4 centimeters thick. That's 3/8 to 1.5 inches, to a depth of 16 inches. When the full depth of cut has been taken, a horizontal saw cuts each slab in turn. These slabs are the first stage of granite tile manufacture. Eight-inch diameter rollers impregnated with diamonds are used to size the granite. On this line, the slabs are fed under 3 rollers, which mill them to the correct thickness, each head removing up to 1/32 of an inch. The next line polishes the tile slab using conventional abrasive before the tiles are cut to length with diamond-tipped circular saws. The final process also uses a diamond tool, a milling cutter, which mills the edges square. The finished 3/8 of an inch thick tiles are used for wall cladding, but 1.5 inch thick tiles are made in the same way for facing stone steps. Another major use of stone is for making monuments, and many stone yards specialize in the production of headstones and related stonework. An 8-foot saw slabs the granite, ready for polishing on both surfaces. After primary sawing, large slabs of granite used to be sized and polished using conventional abrasive for every stage of the process. In recent years, diamond tooling has been used for the first 4 stages, the milling to size, primary polishing, and 2 intermediate polishing stages. The use of diamond tooling has reduced machine downtime and increased the speed of polishing, thus doubling production rates. After surface polishing, the slabs are sawn to specific dimensions on small circular sawing machines. The final shaping of a typical headstone is done on a profile milling machine, which has 2 13.5 inch diameter diamond milling heads, mounted together to form a width of 5¼ inches. Guided by a cam, the shape is milled in the stone in a single pass. The cutters carry 20 diamond segments, each 3/8 of an inch long. The final edge polishing is carried out with conventional abrasive. Prior to this, a diamond milling head does the majority of the work by squaring the edge and creating a flat surface. The cutter removes from 20 to 40 thou as the workpiece travels through at a speed of 14 inches per minute. At the final stage of finishing in the monumental mason's workshop, diamond drills prepare the stone for the metal lettering. It's come a long way from the diamond wire saw in some distant quarry. Decorative work on a grander scale has been going on at Cologne Cathedral since they started restoring it in the 13th century. In more recent times, the close proximity of German industry has increased the speed of decay due to increased pollution. The diamond tools are used to rough out the shapes, which are then finished using traditional methods, so cutting the time involved from 2 days down to 1 hour. The stone being used is still the basalt from the Gießen area, from which the cathedral was originally built. Nothing can replace the craftsman, but today diamond tools are making the job considerably easier. Cologne Cathedral is one of the foremost buildings in Germany and continues to be a monument to the stonemason's art. Typical of Debeers products used in diamond tools for the stone industry are SDA 100S, the premium quality in the SDA range of synthetic abrasives. Most circular saw blades use grit from this family. EMBS, an accurately graded natural diamond grit, is particularly popular in applications where good keying and free cutting are required, such as frame sawing. And Debeers, a premium surface-treated, blocky, natural diamond material which shows good potential in dry cutting blades for building material. From removal of the stone from the quarry through all the stages of production, diamond tools are increasing throughput and enhancing the quality of the finished product. The wide scope of tool usage and the varying demands of stone as a building material necessitate the availability of a wide variety of diamond products, both synthetic and natural. Using the latest synthesis technology and controlled processes for grading, sizing, and quality control, Debeers Industrial Diamond Division manufactures an extensive range of high-performance synthetic and natural diamond abrasives, enabling the diamond toolmaker to meet the demands of efficient production, making stone with its beauty and durability even more competitive with other cladding materials.